Just as a reminder, at the beginning of each session with trig, make sure you set your mode to degrees, right? Okay. And this page here, this starts out with a problem which can be solved with the techniques that we learned for this unit and also with the techniques that we already know. And I think it's more easily solved with the old techniques, but we'll see later how this could be solved with the new techniques, okay? So basically what it says is if you have a Ferris wheel and you drew a horizontal line through the middle of it, they want to know when, and this radius happens to be 70, okay? They want to know when does the passenger pod, reach a height of 30 relative to this horizontal line. And that happens in two places, right? It happens at this angle, and it also would happen at this angle, right? And the angle is measured from the x-axis in a counterclockwise direction. Okay, so they're wondering what the solutions are for these two triangles. I'm going to draw the blue triangle bigger. So this blue triangle has a opposite of 30 and a radius or hypotenuse of 70, and this of course is a right angle. They want to know what this angle is. So remember how to do that? You just do SOHCAHTOA. In this case you would use sine because you have opposite and hypotenuse. So you would have the sine of theta is equal to 30 over 70. So you would find 30 over 70 is 3/7, right? And then you would do the inverse sine of 3/7, right? So we'd go inverse sine 3 divided by 7. And the answer is 25.4 degrees. Okay. And the other question is, what about the green triangle? Now, there's two ways to do this. One is, the green triangle looks like it would be a reflection of the blue triangle, right? Because it's exactly on the opposite side and it has the same height. So to get the reflection, you could do 180 degrees minus 25.4. So 180 minus 25.4. Oops. 180 minus 25.4. 5.4. And so the other angle would be 154.6 degrees. Okay, that would be the second theta angle. Another way you could do it is you could graph the function sine. So I'm going to put sine of x here. And then I'm going to see when sine of x equals 3/7. So I'm going to graph that. So since the window wasn't sized correctly, I go to the window and I'm going to change the x interval from 0 to 180 because I know my answers are from 0 to 180. And then I'm going to change my y min to -1 and my y max to +1 so that I don't waste a lot of space in the graph. I can see everything really well. And this is what I get. The red line is the 3/7, which I put into y2 because I want to see when these two intersect each other because those are the two solutions, okay? The first solution I already have. It was 25.4, right? If I did a second calc intersect here, it would give me 25.4. Let's say that I didn't know what the second one was, and I didn't know that it was symmetrical, so I didn't subtract it from 180. Let's find out this one using second calc intersect. We'll go second calc, intersect number 5, and then first curve is the sine x, yes. Second curve is 3/7, yes. And then the guess, what I want to do is I want to put the cursor more toward the second intersection because that's the one I want to know. And then I press enter. And it tells me that the second intersection is 154.6, which is what I got, right? Okay? All right, that might have seemed difficult. Let's do a few more problems, and then they're similar, and then you can practice using this method of intersection. So 2a, solve the following equations. They give us one equation, which is sine of theta equals cosine of theta, theta 1 to be precise, and the theta 1 is between 0 and 360. They want to know when sine of theta and cosine of theta are equal. And so let's use graphing to solve this. There are multiple places where this is true. So what we're going to do is we're going to put sine of theta in for y1, and then we're going to put cosine of theta, and instead of theta we're using x, right, for y2, and then we're going to graph it, and this time we're going to put for our domain 0 to 360, so we go into window, and instead we had 0 to 180, but now we're going to put 0 to 360. And then we graph. Oh, we forgot to take out the second function of 3, or no, we did. We took out 3 sevens because we overwrote it with cosine theta, right? There's sine theta. And then here's cosine theta. And so now what we're going to do is we're going to find that intersection point, the first intersection point, and then we're going to find the second intersection point. Okay? So how do we do that? We do second calc intersect, which is number 5. And then it says first curve is the blue one, yes. For second curve is the red one, yes. And what's your guess? We're going to take our cursor and put it closer to the first intersection. You can type in a number here. I'm going to type in like 50. Okay, and there's my guess, and then the intersection turns out to be 45, 0.707. So the theta value is the x value, so it would be 45. Okay, so the first answer is 45, and then the second answer would be over here to the right side. So let's do second calc intersect again. Second calc intersect number 5. And then the first curve is the blue one, yes. Second curve is the red one, yes. And the guess, I'm going to put something closer to 360 because the second intersection is closer to 360. I'm going to put 300. Enter. And then it finds this one, which is 225. So that's the second one. And these are degrees, so you could put 45 degrees and 225 degrees. Then the next one says, what are the theta values in which sine of theta is equal to 0.8 and also between 0 and 360 degrees. Okay, so let's do that. So we'll go into y equals, and the first function is going to be sine of theta, and the other one is going to be 0.8. And then we're going to graph that, and we're going to have a sine function, and then we're going to have a straight line, horizontal line at 0.8, and then we're going to find out where they intersect. Okay, so we're going to do second calc intersect again. Second calc intersect, second calc intersect number 5. And then we're going to put the cursor closer to the left intersection. I'd say that's like at about, I don't know, 45. Graph. Second calc intersect number 5, and the first curve is the blue one, yes. Second curve is the red one, yes. And then our guess, I'm going to move it over a little bit, but it's going to take too long, so I'm going to type 50 to get close to the first one. And it says that the intersection is 53.1. So the first intersection happens at 53.1 degrees. And then I'm going to repeat it to find the right side intersection. So second calc intersect number 5. First curve is the blue one, yes. Second curve is the red one, yes. And then for my guess, I'm going to put something like 120 to get the right one. I wanted 120, not 12. It's really hard to press these buttons. It's driving me crazy. Second calc intersect 5. Enter. enter. And then I need to move the cursor over to the right side. So I'm going to put like 1, 2, 0. Enter. And then it finds the other one. So the other one is, oh, it turns out to be pretty close to 120. It's 126.8. So I'm going to put like 127 degrees. You're like, how did you know it was 120? Well, I know that the entire width of the thing is 360, so it's a little bit less than 180. I just guessed 120, okay? And it was pretty close, but it wasn't exact. All right? All right, let's move on to number 3. Jakob models the average monthly temperature T degrees Celsius in Warsaw with this function on the domain 0 to 11. T is the time measured in months with T of 0 representing the average temperature in January. Okay, so T of 0 represents January, so 11 would be December, right? Predict the average temperature in May. Well, if January is 0 and 11 is December, then May would be 5 minus 1, so it would be 4, right? So we're going to check to see what the value of this function is at little t equals 4. So how do we do that? Well, they gave us a function, and remember in our class, whenever they give you a function, you should always graph it. So this is no exception, even though it's a little different than usual. Negative 11 cosine parentheses 30, and we're going to put x instead of little t. And then we're going to put plus 7.5. And we're going to graph it using the domain from 0 to 11. 0 to 11. Okay, graph. And it's going off the edge of the graph. Let's adjust it. How do we adjust it again? We adjust it using zoom fit, right? So zoom. It's still graphing, so there, maybe it's done now. Zoom fit, which is option 0. Okay. All right. And now what we want to know is we want to know the temperature in May. There's two ways to do this. One is with the graph and one is with the table. With the graph, what you do is you do trace and then 4 for May. Enter. And then it says that the y value is 13 then. So I would put that the answer is 13. Okay. The t is the 4 and the big T is 13. Okay. And the other way you could do it is you could do a table. So second table, and then you could find 13 here in the x, find t equals 4 on the left side, x equals 4, and then that would give you that y is equal to 13, right? This takes too long. Okay, it doesn't take that long on a real calculator, it takes long on this virtual calculator. Predict when the average temperature would be 0. And so there's a couple ways to do that. One of the ways is to look here, and I can see that looks like there'd be 2 places. One is between month 1 and month 2, right? Looks like there would be a 0 there. And the other is between month 10 and month 11, right? So I can already see from this that it would be like, remember, month 1 is February and month 2 is March, because 0 is January, right? So you could say that it's like between between February and March. And the other time it happens is between November and December. Between November and December. And when you can like find the exact point by doing second calc intersect. So we'll do second calc, or actually not second calc intersect, second calc 0, because we want to know when it, second calc 0. We want to know when the temperature is 0. So we move our cursor over to get to the left of the x-intercept here. Let's just type 0 and it'll go over there. Okay, and then the right bound would be slightly to the right. We'll put like 3. And then our guess, it doesn't matter because there's only 1. And it says 1.57. Okay, so 1.57 gives you a more exact value about like where exactly it is between February and March, right? Actually, if you consider, I'm not sure exactly how they're doing it, right? So they say 0 is January, but they don't say if 0 is the middle of January or if 0 is the beginning of January. If 0 is the beginning of January, then 1.57 is actually the middle of February, right? And if 0 is the middle of January, then it's different. They didn't say. So I think between February and March is an okay answer. It's impossible to say. They didn't give us enough information. Okay, and then where exactly between November and December, you could find that by doing second calc 0 for the other side. So we'll do second calc 0, which is option 2. And then we will move the cursor over to about 10 or so. And then we move the cursor over to about 11. And see what we get. It's and then the guess. Just hit enter. 10.43. Okay? So it's either halfway between November and December, or maybe it's like the middle of November, depending on what is the meaning of 0, which we don't know. Okay? All right. Number 4. Susanna models the depth D of seawater in the harbor H hours after midnight with this function. Okay. Predict the depth of the water in the harbor at 5:30 a.m. Okay. So, does this say 5.3 a.m.? It says 5.3 a.m. If it was 5:30, it would be colon and it's period. So that they're just like saying, just put 5.3 directly into H. That's fine. So we're going to put this function into the calculator since they gave us a function. It's going to be 1.8 sine 30 times x parentheses plus 12.3. And we're going to graph that. And basically, H hours after midnight, so this basically can go up to 0 to 12 or 0 to 24. It doesn't say what the domain is, right? But they just want to know for now, what is the depth of the water at 5.3 a.m.? So what we're going to do is we're going to do trace 5.3, and that will give us the height at that time, 5.3. And it turns out that it's 12.9. Looks like 12.9. Okay. And then it says predict when the depth of the water in the harbor will be 10.9. So there's a couple ways to do that. One of them is to look at the table. If we look at the table, we can kind of see that 10.9 would be between 7 and 8, but we want more precision than that. So we go back to the graph, and then we make a second line, and we're going to make a horizontal line at 10.9, and then we're going to see what the intersections Okay, so it looks like there's two intersections here. So I'm going to find the first intersection at least. I'll do that by doing second calc intersect, which is number 5. And the first curve is the blue one, the second curve is the red one, so I hit enter twice. And then the guess, I'm closer to the left one already, so I just hit enter for guess. And it's 7.70 a.m. Okay, and then the one that's right next to it, we want to know that one too. So we'll do second calc intersect, number 5. And then so the first curve is the blue one, yes. Second curve is the red one, yes. And our guess, we want to put something a little bit more to the right. Let's say something like 9. Oh no, that wasn't close enough. We need to go a little bit more to the right. Maybe like 11. So we'll try that again. Second calc intersect, number 5. First curve, enter. Second curve, enter. And then we'll type in 11. And it'll give us the other one, which is 10.3. 10.3 a.m. And then the question is, okay, if we look at 0 to 24 hours, are we going to only get those two intersections, or are there more? So I'm going to change my window so that it goes from 0 to 24. And then I'm going to graph again. Oh, it changed it to 2. Darn it. And it takes so long to come back. What I'm going to do... Gosh. Oh, I hate this virtual calculator. Okay. Let's go back to window. And then I'm going to change X max to 24, not 2. And then I'm going to graph again. And we'll see if there's more intersections than just those two. And if there's more, then we're going to need to do that again. Okay, looks like there would be 2 more, right? Yeah. So let's get the third one. We go second calc intersect, number 5. And then we hit first curve, enter, second curve, enter. And then this, to put a guess for the third one, looks like it would be at about 18 or so. So I say 18. And it gives me 19.7. Okay, and then the last one's slightly to the right of that. So I'll do it one last time. First curve, enter, second curve, enter, and now I'm going to put like, I don't know, 23. And it gives me 22.3. Okay, 19.7 is obviously PM. If I want to convert it to PM, I would subtract 12 and it would be like 7.7 PM. But these are like weird times, right? Because they're not even converted to minutes, and they didn't ask you to do that. So I think it's fine. Okay. So these are the times, these are the times, the 4 times when the depth of the water will be 10.9. And that's it for this page.